I'm Keras from Guitars AI, and we continue scratching the surface of deep learning, working on a problem of musical instruments classification. This time we are going to use the sequential model in Keras, and also we will use scikit-learn wrapper, and we will use a grid search like we did previous with different models. So the idea is that we will create a model using Keras sequential API, and then we will change different parameters doing a grid search using different optimizers, using different numbers of layers, different numbers of hidden units. So let's get started. As usual, we import our libraries, our Python packages. This time we are using the sequential Keras model. We're also using the Keras classifier, which is the scikit-learn, a wrapper for the scikit-learn API, so we can use the grid search with cross-validation like we used before. We're still using the MFCC as an audio feature, so everything continues the same. We are loading our vectors of labels, our vectors of features, and separating a train set and a test set. Then we reshape, we do the one-hot encoding. So you can find the documentation for the Keras sequential model on this link. And basically the sequential model is a linear stack of layers, so we can pass layer instances to the constructor, and we can also create a model and use a method add method to add layers. So we can for example add a dense layer, then we pass the which activation functions we're using, and this way we can build a sequential model. The first layer, it's the input layer, and we must pass the dimensions of this for the first layer, and the other layers will get the dimensions from previous layers. So at this point we're defining a function called create model that will return our sequential model. So as an attribute as a default, we're passing the layers, which activation function and which optimizer we will use. So for the sequential model, we create a model which is a sequential model. The first layer, we must pass the input shape. So this is why there is this part here. And as a default, it will have an input layer with 4 hidden units. So it will stop here, and then it will go and add an output layer with 6 units and the softmax activation function. It will compile the model with cross entropy, the categorical cross entropy loss function, and we return this model. So we can pass a different attributes, so we can pass a different activation function, a different optimizer, and a different layer structure. So for example, we can pass 4 layers with different number of hidden units in each layer. There will always be the output layer with 6 units and the softmax. At this point, using a Keras classifier, so the Keras classifier is a wrapper for the scikit-learn API, and then we can build a model and use the scikit-learn grid search method, for example. So as a model, using the Keras classifier, we are passing our create model function we defined here, the number of epochs, the number of batch size, and then we create our model. To use the grid search, we will have these parameters that we need to define. We will make experiments with 1, 2, 3, 4 different network architectures. One just with 12 units in the input layer, one with 12 units, and then another layer with 6 units, another one with 6 units, another layer of 6 units, another layer of 6 units. And we are using 2 different activations functions, relu and tonnage, 2 different optimizers, different number of epochs, and batch size. So I recommend that you run it locally because it will take a long time to do this grid search with cross-validation, going through all the different activation functions, optimizers, the different network structure, the different numbers of epochs, and it will take a long time. So here, as we did with other models, we are using the grid search. We pass the model that we create using the Keras classifier. We pass the parameters, param grid, like here. We can fit, so we pass our train set, our train classes, and it will start to train the model. So this is a long process. It will take a very long time to finish, but after it's trained, it will return us what were the best parameters, the result of our grid search. So the best activation function was relu. We didn't really pass different number of batch sizes, so it was 5. Number of epochs was 150. And the best network architecture was with 12 units in the input layer and using an Adam optimizer. So it's interesting to see that sometimes best results could be with a deeper network. Sometimes a shallow network would give best results. So it's always interesting to use a grid search and try different parameters. Yeah? So after we define which model is the best one, or what parameters will we can build a model using those parameters. We can train the model, and then we can do the predictions like we did before, and we can also plot the training loss and validation loss like we did before with different models. We can plot the accuracy for the training and the validation like we did before. We do the predictions. We have the different evaluation scores, so we can have a recall, precision, the F1 score like we do to evaluate our model. We can also plot the confusion matrix, and it will tell where the predictions went wrong. For example, it should be a flute, but it predicted as a cello. So this model with 12 input units using the parameters we found using the grid search has an accuracy of 96%, and it made 6 mistakes. So we trained 246 parameters, so it's much less than the number of parameters we trained in the previous tutorial, and the results were quite similar. So I hope you have a grasp now how to use the two different ways to create models with Keras, like we did previously, and now with the sequential. Also how to use grid search, how to use the scikit-learn wrapper, and then it's the same procedure. We define a model, we train, we evaluate, we can fine-tune it, we can use grid search. Yep, that's it. Check you later.